Hey guys, so lesson 3-4, it's all about inequalities. Inequality. Inequality. All right, so what I want to do for pretty much all of these problems on this page is solve for x, okay? And once you solve for x, then you're kind of graph it on this kind of one dimension or one axis line, all right, based on what you see. All right, so if you end up with something that is greater than, okay, you're going to basically color the line. Oops, sorry, I meant to write greater than without that underline, that symbol there. Okay, you'll end up doing like a circle and then shading to the right. Okay, if you end up with less than or equal, okay, then you'll end up shading to the left. And lastly, if you have greater than or equal or less than or equal, you're going to use a closed dot. And if it's greater than or just less than, then you use an open dot. Okay? All right, so here we're going to solve for x. So treat this like it's an equal sign. So literally I'm just going to subtract 2 both sides, subtract x both sides. You get 2x here, and it's greater than or equal to -8. And last step, divide by 2. So x is greater than or equal to -4. So basically I go to the graph and I have an equal to sign. So remember I use a closed dot at -4. If it didn't have the equal sign, then I'd do it open. And it's greater than, so I'm gonna show you to the right. Okay, all the way. All right, so now this one, notice I have a squared, so that means I'm actually gonna have to set it equal to 0, just like you do with the other problems. Okay, so when you're solving a quadratic, okay, we still want to take the same approach and make it equal to 0, okay? So we're going to make it equal to 0 by subtracting 12 on both sides, okay? And then we have 2x minus 5x minus 12 is less than 0. Okay, so now what I'm going to do is I'm going to show you an example that would be similar, okay, but it's not quite the same, okay? So let's just say I've got 2x minus 7x plus 3 is greater than or equal to 0, okay? So what I'm going to do is I need to solve this. Factor it and solve it. Okay, so that means I would need to use x and the box. So I would work through all those steps in doing the x in the box. And what I would end up with here is 2x minus 1 and then x minus 3. Okay, after I do all those steps. So you'll do that with this one. Okay, so then I figure out that my solution is going to be, now it's not an equal sign, so I'm going to use x is greater than, okay, or equal to 1/2. That's from the first part. And then, or x is greater than or equal to order 3. So what I do is I take those points and I'm going to graph them. Now, since it's equal to, on the graph, I want to use a closed dot. But on this one, I would use an open dot. Okay, so when you guys do this one, use an open dot. I'm using a closed dot because I have an equal sign. Okay, so here, remember, don't copy this because you're about to do that problem on your own. Okay, so I would basically put a closed dot at 3, another closed dot at 1/2, which is about right there. And now here's what you got to do to figure this out. You're going to take a point either in the middle or on the outside of those numbers, and you're going to plug it back into your original equation. And you've got to figure out which one will work. The easiest thing I like to do, which is a real shortcut for you guys, is plug in 0. Because 0 is always the easiest thing to plug into one of these equations because it's going to like cancel everything out. So think about it. If I plug in 0 into that equation, well, that becomes 0. that becomes 0. And then I end up with 3 basically. So basically, if I plug in that 0, I have 3 that's greater than or equal to 0. And say to yourself, is that true? Is 3 greater than or equal to 0? Yes, it is. If you answered yes, and remember that number's like on this side of that point, then you're going to shade on that side. Okay? Now, if you shade to the left, that means you will not shade in the middle. Now, you could check a number if you wanted to. You could plug in a 1 and check that to make sure. Because if I plugged in 1, I'll show you real quick. Plugged in 1, that'd be 1 squared is 1, times 2, it's 2, minus 7 times 1, so that's basically 2 minus 7, and then plus 3. So if I did that, 2 minus 7, that's negative 5, plus 3, that's negative 2. So if I plug in plug in 1, I get negative 2 is greater than or equal to 0. Now think about it. Is negative 2 greater than or equal to 0? No, it's not. So these numbers in between those 2 points are not included. Everything outside of it, to the right and to the left, is. Now let's say you do plug in a number in the middle and it does work. What that means is you're only going to shade in the middle and not the left and right. So basically, guys, you're either going to shade outside those numbers or inside the numbers. So you just got to figure out which one works. And all you got to do is check one. All right, so now down here, no more quadratics. All right, so here, absolute value. Now, if you remember absolute value, you're going to have two solutions. Okay, so the first one will be 2x plus 3 is less than 5. Okay, now when you are working with absolute values, you write it again, but you also switch this sign and make this negative. So it was less than, now it's greater than, and then I solve it. So I work through the steps. 2x is less than 2, divide by 2. If I divide both sides by 2, I get x is less than 1. Okay, I do the same thing over here. 2x is greater than negative 8. If I divide both sides by 2, I get x is greater than negative 4. Okay, so now I have x is less than 1. So here's 1. And remember, that doesn't have the equal to sign, so I put an open circle. And you're greater than negative 4. Open circle there. So it's less than negative 1. Less than 1, so that means I should be shading to the left. And greater than 4, so that means I need to shade right in the middle. Okay? So now notice, these are all absolute value of 2x plus 3 with a 5 on the end. So what that means is I'm going to end up with the same numbers after I solve this each time. Okay, so I don't need to solve this a bunch of times. And then look, it's almost the same down here. I know it looks the same, but that's a minus 3, not a plus 3. So that's my, oh, and actually, I'm sorry. I just realized this one will not be the same, because that's a minus 3. Okay, so these two will be the same, all right? And then once you guys figure this one out, you should be able to do the rest of these. All right, so now here, the only difference now is that I want to have an equal to sign. Now the first one would be greater than or equal to. So the first one to the left will be that. And then when I go over here, I'm going to switch it. It'll go the other direction. Okay? So now x is greater than 1. So now closed out this time at the same points. It says x is greater, so I go to the right. And x is less than negative 4, so I go to the left. Okay? So now here, you guys will basically do the same thing. So what you did in these first two, you're going to do for these next two. Now, the only thing is with this one, you need to remember that when you divide by negative 2, when you divide by a negative number, it's going to flip that sign. So I'm actually going to show you this real quick. So 3 minus 2x less than 5, and then you're going to set it up again. 3 minus 2x, remember, switch the sign here, and then make this number negative. So here, I'm going to subtract 3 -2, and then +2. I'm going to divide by a negative number. Anytime you multiply or divide by negative numbers, it switches the inequality sign. So now I end up with x is greater than -1. Okay, and then you'll do the same thing here. You're going to need to switch that sign when you solve it. Okay, and then you guys will graph that. All right, so now that here are the ones on the bottom. You're going to be solving these inequalities. So again, same approach that you took up here, except you're not required to graph it. Okay, so still set up two different inequalities. Keep the left side the same, but then you switch the sign and change the number, whatever's on the right, you change it to negative or just switch the sign. Okay, same thing here, except what you guys are going to need to do here is get rid of that fraction. So you'll need to do kind of what we always do to get rid of fractions and multiplying. Okay, so switch the sign, make it negative. So here, what I would do is multiply everything by 2. And you'll do that to this as well. Okay, and then the steps are the same to solve. Okay, and then same thing here. Okay, split them, make one side, keep the left side the same, and then switch the right side. All right. Now on the back, okay, you've got some inequalities, except they're not absolute values this time. So this one's going to be very similar to the very first one. Solve for x. Okay, solve for x. And then you're just going to have 1 point on here, and then you're going to either go left or right depending on what you end up with here. It's a less than, so you're probably going to be going to the left. Okay, here is a quadratic. Now I'm going to help you on this one. Notice that yes, it's a quadratic, and yes, it's squared, and maybe you're thinking equals 0, but you only have an x squared, and there's no other x. So in this case, I'm actually going to want to subtract this from both sides and get x squared is equal to, what is that, 36. And now I'm going to square both sides, square root both sides. So I get x is greater than 6 and x is greater than -6. So what I'm going to have to do is at first it's open because at -6 and at +6. And remember now you're going to take a point, plug it in. I recommend just plugging in 0 into the original equation. If 0 does not work, do not shade here, only shade on the outsides. If 0 does work, then you're going to shade on the inside. That was kind of like the second question I showed you. Okay, so now that should help you guys figure out the rest. So now you still have inequalities here, guys, but it's just kind of like next level. Now you got to distribute first. And then, so here I would distribute, right? Still solve for x. Just again, treat this like it's an equal sign. Subtract the 4x from this side, subtract the 6 from this side, and then solve for x. And then you'll end up with x is greater than or less than, depending on what happens. Now, what I notice here, and let me just kind of show you this first step. Okay, I'll take that away, and then I'll take the 6 away. Is here I'm going to have -x is greater than -13. I'm going to have to get rid of that negative. So in order to do that, I'm going to have to divide by -1 on both sides. So I guess I am showing this to you. Which means that when you divide by negative, guys, switch that sign. Okay, now it's your turn. Now it's your job to graph that on that line. Okay, so I know that, yeah, that I guess we didn't help you guys out because 13 doesn't fit there. So just kind of like write it somewhere over here, maybe, and then shade it. Okay. All right, now here again, I've got a quadratic. So guess what? You've got to get this equal to 0, or really it's got to be less than or equal to 0 in this case. Okay, so we want 0 on the right, and then you're going to have to, once you get it 0 over here, then you're going to have to use the x in the box and factor. And then once you get those 2 points, which are going to be solid dots because I have equal to sign, you're going to have to test a point and figure out where to shade, inside or on the outsides. Okay. All right. So now here, same thing, quadratic. So you're going to get 2 points, just like this one, or the very first one that I showed you guys how to do that. So refer to this problem on how to do that. Make sure you test the point to see where you're going to shade, whether it's inside of it or outside of it. Okay, here, that's just like the front page. Okay, that's going to be just like these ones. Split it. So copy this one to be able to do that one, okay? So go back to the front page for that one. And then this one is going to be very similar. You just got an extra step here. Here, I'd probably divide that too. Cancel it. And now the steps are going to be the same as this problem. You're pretty much going to be doing the same thing. Okay, here, again, you're just kind of eliminating those numbers on the outside. Okay, this is a cubic, so a little bit different. So we'll kind of work through this one a little bit together. Okay, so I would subtract that from both sides. Okay, I get 130 out here, 3x minus 6. I want to get rid of that fraction, so I'm going to multiply 3 on both sides here. Remember, you don't multiply 3 into the parentheses, just that fraction there. So I'll get rid of that. Okay, so then I end up with 27. Sorry, I just had to look at my notes real quick. So now I have a cube on both sides. And if you remember, when you have a squared or a cube here, what you can do is do a root. So in this case, we'll do a cube root. That cancels that out. And then I get 3x minus 6 is less than cube root of 27, or number that I multiply 3 times to get 27, is 3. And now you solve for x and then graph it on the line. All right, and that's it.